Hi everyone, in this video we're going to go through 9J, the product rule. So we've already gone through the chain rule, and there's also the product rule that you need to know and the quotient rule. So the good thing is, if you're familiar with the formula sheet for your exams, the chain rule, product rule and quotient rule are on there, as well as the derivatives of some other functions. So it's probably a good idea to think about, well, what is on the formula sheet before you think, oh my gosh, I need to learn all these off by heart. And I think in the previous video when I did trig functions, I said you need to remember these, and then I think I realized they're on the formula sheet. So I haven't double checked, but I'm pretty sure they're on the formula sheet. So it's a good idea just to properly check that. All right, let's move on. So the product rule, when you think about it, the word product means to multiply. So when we've got two functions multiplying by each other, so when we've got 2x squared plus 6 multiplied by 2x cubed plus 1, so we would use the product rule. But something like this, I would actually probably not use the product rule. Isn't that funny? I just say, well, you're going to use the product rule, and then I said we won't. Now, the reason I probably wouldn't use the product rule for this is because it can be easily expanded. All right, so I'm going to show you both ways. So we've got 2x squared plus 6, 2x cubed plus 1. So if I was going to expand that, just remember you're expanding each term like so. So we've got 2x squared times 2x cubed is 4x to the power of 5. Just making sure that's right. Plus 2x squared plus 12x cubed plus 6. So instead of having it in factorized form, I've now got it in expanded form. So if I'm finding the derivative of this, it's going to be 20x to the power of 4 plus 4x plus 36x squared plus, nope, not plus 6, that 6 goes. All right, so the derivative isn't that hard to find, but if I compare this to D, or actually we'll do C, if you have a look at this bracket, it's to the power of 3. So if you expanded that, and you can do that, but it will take you a long time to do. All right, so sometimes it's easy, I think it's easier just to expand and then just find the derivative, or you can use the product rule. So you will notice that some functions you can find the derivative multiple ways. So this, for example, this one here, I can expand it and then find the derivative. I don't have to use the product rule. You might come across a few quotient rule type questions, and you can turn them into a function so that you use the product rule. And sometimes there might be cases where you've got the product rule and you can use the chain rule. All right, so I'm just going to show you how to use the product rule with 1A now. All right, so when you're doing the product rule, you let u equal the first function or the first part. So in this case, 2x squared plus 6, what I highlighted in blue, and we're going to let v equal 2x cubed plus 1. All right, so if you have a look, and I'll just change this from pink because pink's quite hard to see. So we've got u and v. So the next part of using the product rule is we've got to find du dv, and we've got to find dv du. Now make sure your v's and your u's don't look the same. Not div, oh my gosh, what am I doing? Du dx and dv dx. There we go. Silly me. All right, so we've got 4x for du dx, and then dv dx becomes 6x squared. So using the product rule, we're going to substitute all this in. So d dx. So the first part of the product rule, I'll make that a bit smaller so we can actually see the, not that small. Come back, pick up. Sorry. Oh, where am I? There we go. All I want to do is see the, there we go. See the product rule. All right, so we've got u. Now, because we've got two terms in u, make sure you put it in brackets, okay? Now you could do brackets up here if it helps. Probably should have. Okay, because on exams, if you get a question like this and you forget to put your brackets in, and then you make an incorrect multiplication, you're going to get it wrong. And it's a shame to lose 1 or 2 marks on a question that is pretty easy. All right, we multiply u by div dx, so 6x squared, plus v, so we put that in brackets 2, times du dx, which is 4x. All right, let's just tidy things up a little bit. So I've got 6x squared, 2x squared plus 6, and then plus 4x, 2x cubed plus 1. Now, we can easily expand these brackets. So I'm going to go ahead to do that so that we can see we get the same answer as we did up here. All right, so 12x to the power of 4 plus 36x squared plus 8x to the power of 4 plus 4x. All right, so let's just tidy that up. So I'm going to have 20x to the power of 4 plus 36x to the power of 2 plus 4x. And you can see we get the same thing. But using the product rule in this case is a lot longer, takes a lot longer than just expanding and then just finding the derivative. So just be aware of, if on an exam, if you had a question like this, I would probably expand it. Don't automatically assume that you use the product rule. You can use the product rule, obviously, but it's so much more time consuming. And you can see because there's a lot more working out, you're more prone to make an error. All right, let's do something else. So for the rest of them, let me just do a quick check though. So question B, I would probably expand that and not use the product rule. But for everything else, I would use the product rule for. Okay, so let's just do C and then we'll do one of the harder ones. So for C, obviously you can expand 3x times 2x minus 1 cubed, but that's going to take you a long time to do. So let's just use the product rule. So we're going to let u equal 3x and v is going to be 2x minus, oh, do you know what? I've just realized I'm going to run out of space there. So let's just do it down the bottom. Because what we're going to have to do with this one is use the chain rule within the product rule. All right, so question C, can't remember what it was, 3x, 2x minus 1. And that was cubed. Might just double check that that's correct. Cool. All right, so let u equal 3x and v is equal to 2x minus 1 cubed. All right, so just separating them into 2 parts. So we've got the 3x times the 2x minus 1 to the power of 3. So don't forget that power. So du dx, easy peasy Japanesey, it's going to be 3. Div dx, on the other hand, you're going to have to use the chain rule. Now, if you're quite familiar with differentiation, you might be able to do the chain rule in your head, all right? It's actually not that hard to do in your head, but I'm going to do it on paper. All right, so the problem with doing the chain rule within the product rule is we've already defined u as something. So if we're going to use the chain rule, I don't know, I still kind of like to use u, even though we've got let u equal something else, but I'm going to let u equal 2x minus 1. So that means v is equal to u cubed. All right, so we're just finding the derivative of this, div dx, in this little square. All right, so du dx is equal to 2 and dv dx is equal to 3u squared. So dv dx, and I just realized I wrote x there, it should be u, dv du. Okay, so we're going to have 2 times 3 is 6, u is 2x minus 1 squared. So dv dx 6 2x minus 1 squared. And then that x doesn't look like an x. There we go. All right, so with your product rule, and you can scroll up if you, well, you can't scroll up because you can't scroll up on my computer screen. You can see your notes though. It's u times dv dx, so 3x times 6 2x minus 1 squared plus v times du dx. Now, because of 3, I'm going to put that out the front. It doesn't matter that it's in a different order. All right, let's tidy that up. So we've got 3 times 6 times 3. So that's going to be, no, it's not. What am I doing? There's no multiplication sign there. 3x times 6 is 18x. 2x minus 1 squared plus 3, 2x minus 1 cubed. Now, you can, if this was an exam, leave it like that. All right, so usually in the exams, if you read the examiner's reports like you should be, they'll often say that students go on to expand or factorize and make errors. But what I'm going to do here is I am going to factorize it. All right, so you can see we've got the common factor here, 2x minus 1 and 2x minus 1. And we've got a power of 2 here and a power of 3 here. So I can actually take out 2x minus 1 squared as a common factor, and I can also take out 3 as a common factor. So 3, 2x minus 1 squared is a common factor, and then I'm left with 6x times 2x minus 1. Running out of room. All right, let's just tidy that up. So 2x. All right, I've just made a mistake. Let me just fix it up. That should be a plus there. Sorry. I had a tickle in my throat. So 6x plus 2x is 8x. And then we've got minus 1. All right, so as I said, in an exam, all right, that would probably be okay with that, especially if it's only worth 1 mark. But you do need to be able to go to this step here. So sometimes on an exam, they might ask for a specific format. Otherwise, the first answer is fine. But if it wanted you to take out that common factor of 3 2x minus 1 squared, you need to be able to have that skill as well. All right. Just thinking here, what I might do, instead of doing some of these, I might just show you quickly. So f, you've got x squared plus 1, and that's times 2x minus 4 to the power of a half. Okay, so remember the square root is the same as to the power of a half. All right, let's move on to question 2 because we've got quite a few more examples to do. All right, so here we've got all base E questions. So I might just jump and do C, and then I might do D. All right, f of x equals e to the power of 4x plus 1, x plus 1 squared. So we're going to have to use the product rule. So we're going to let u equal e to the power of 4x plus 1, and then v equals x plus 1 squared. So again, we're going to have to use a chain rule there. Du dx. So what are we going to have? 4 e to 4x plus 1. And then dv dx, that's going to become x plus 1. Sorry, 2 times x plus 1. All right, so f dash x, haven't left you much space for these questions, I apologize. Still using your, the product rule. Even though I'm using u and v, just make sure your final notation, you're using f dash x as opposed to dy dx. All right, so we've got u times dv dx, so what is that going to be? 2x plus 1 e to the 4x plus 1. And then v times, oh gosh, I'm not going to have enough room. Might write underneath. All right, so e dv dx, so 2x plus 1, and then we're e to the 4x plus 1 plus x plus 1 squared, or e to 4x plus 1. All right, taking out a common factor again. So I can see we've got 2 is common. So we've got 2 and then 4. So 2 is common to both of them. Then we've got x plus 1. And then I've got e to the power of 4x plus 1. So that is common to both. Okay, so you can see the 2 there and 2 also goes into 4. We've got x plus 1 here and x plus 1 here. And then base e to the power of 4x plus 1 on both sides as well. So they're going to take that out as a common factor. And then we're left with 1 plus 2x plus 1. All right, and I probably should tidy that up a little bit. 2e 4x plus 1 x plus 1 times 2x. It's going to be 3 plus 3. All right, in the textbook, it has multiplied this 2 into the first bracket, so I might go ahead and do that as well. So that's going to be 2x plus 2, 2x plus 3. But obviously, like, I could then expand that, not that I really want to, because factorized is probably the best form. But with methods, make sure your algebraic skills are up to scratch. Okay, because you need to be able to go, I guess, from this part here to this part here. All right, I'm just thinking whether we should do another one from question 2. We might do D. So let's move this question to the next page. All right. Got f of x equals e to the power of negative 4x square root of x plus 1. And it's just saying that x has to be greater than or equal to negative 1 because we're not taking the square root of a negative number. All right, so let's let u equal e to the negative 4x. So that means v is equal to x plus 1 to the power of a half. So du dx becomes negative 4e to the negative 4x, and dv dx becomes, now you'd use the chain rule and you'll get this. Oops, that's a half. Does that even look like a half? Maybe I'll rub that out and try again. Which is the same as 1 over 2 root x plus 1. All right, and du dx becomes, what is that going to become? Negative 4 over e to the 4x. Okay, so your derivative, we're going to do u times dv dx. So I'm going to write u with a positive power, so e to the 4x times dv dx, 1 over 2 root x plus 1 plus, and then b is the square root of x plus 1 times du dx, which is negative 4 on e to the 4x. All right, so we just need to tidy this up a little bit. So multiply your numerators, then multiply your denominators. So we're going to have 2e 4x square root of x plus 1 plus, and then on this side we're going to have negative 4 square root of x plus 1 over e to the 4x. Now what could happen here, you can have everything over the same denominator, but what I've got here is fine. The only thing I probably would do is get rid of that negative, that plus and make that a negative there. If you needed to have the same denominator, then you need to multiply through by, so both denominators have e to the 4x, which is fine, but I need to multiply this one by 2 root x plus 1. So that becomes then on the denominator, and whatever I have on the denominator, I have to put on the numerator, so I'm still multiplying by 1. All right, so if I did that, I would end up with on the top 1 minus 4. Now the square roots will cancel out. Actually, I'll do the 2 times 2. So the square roots will cancel out and I'm left with x plus 1. And then on the denominator, I'm left with 2e for x root x plus 1. All right, let's just tidy this up a little bit. So what is that? 8 minus 8x minus 8 over 2e for x square root of x plus 1. All right, so we've got negative 8x minus 7 over 2e for x square root of x plus 1. Now that 2 on the denominator does not cancel because on the numerator we have 2 terms. Okay, so just make sure you don't cancel that 2 with the 8 or anything like that. All right, so yeah, do make sure that you can get to that final answer, and I just checked and that's what the textbook has got. All they've done is brought that common denominator, so that's a skill that you must have, but it doesn't mean that you necessarily have to do that. You need to look at the questions. So usually questions like this are at the start of exam 1 and would be worth probably 1 mark. So you're not expected to go that extra step to put them on the same denominator unless it specifies. All right. I think this is going to be quite a long video. Question 3. What do we got? Now we've got some logs. Let's do C. I'm not going to do it too many here. Let's do 3C. F of x equals e to the power of, oops, got the equal sign, log e to x. All right, so we're going to have u equals e to the power of x and v equals log base e to the x. So du dx is just e to the power of x, and dv dx is 1 over x. So just understanding the derivative of e and log. Excuse me. All right, so f dash x becomes u times dv dx, so e to the power of x over x plus e to the x log e x. All right, again, there's nothing wrong with leaving it like that, but I'm going to take out e to the x as a common factor. And we get that. All right, so not really that tricky, because if you can find the derivatives, you can use the product rule and you can also do the chain rule, but we haven't learnt the chain rule yet. All right, so lastly, question 4, hopefully. Cool, and then we're moving on to the quotient rule. All right, so let's see, which question can we do? Let's do C. Don't know why this one's here, because I would use the chain rule for this one, not the product rule. All right, so letting u equal e to the 2x plus x, so that means we've got y equals, even though it's no y, but we'll let y equal u to the power of 3 on 2. So using the chain rule here, don't know why there's a mix of chain rule in there. Anyway, so that's 2e 2x plus 1, and then dy du is 3 on 2u. 3 on 2 minus 1 is a half. And then d dx, so we're going to multiply them. Remember, we're using the chain rule, not the product rule. And we're going to have to put this in brackets because there's 2 terms there. 2e to the 2x plus 1 times 3 on 2 times u e to the 2x plus x to the half. All right, we do need to tidy that up. So because of this fraction 3 on 2, that means the 2 is on the bottom, 3 is on the top, and then we've got 2e2x plus 1, and then we've got to the power of a half, so it's going to become the square root of e2x plus x, and just extend that line, or it's called a vinculum, so that it covers everything. All right, just having a look at some others. So even f, instead of doing the product rule, you could just expand it. So I might actually do that one to show you. So we've got x squared plus 2x plus 2 e to the negative x. So you can multiply, oh, actually, now I'm thinking that's probably not going to be the easier thing. All right, I'm not going to expand it. Let's change my mind. Let u equal x squared plus 2x plus 2, and v equals e to the negative x. I'm going to run out of space. Let's write a bit smaller. 2x plus 2, so dv dx is negative e to the negative x. So d dx, u times that, so I'm going to run out of space, times negative e to the negative x plus e to the negative x, 2x plus 2. All right, so I can take out e to the negative x, which is the same as 1 over e to the x out as a common factor. And then I'm left with, there's a multiplied by that negative, so that negative can just stay out there. And we've got x squared plus 2x plus 2, and then 2x plus 2. All right, so I'm going to leave it there because it's quite a long video, but please make sure you understand how to use the product rule. As I said, it is on your formula sheet, so as long as you can find the derivatives of functions, you can use the product rule. All right, guys, bye.